Welcome to another deep dive for GCBASIC. This is looking at graphical LCDs, concepts of operations. I'm going to do a bit of a deep dive on how they actually operate. It's quite interesting. So this is January 2025. Subscribe, like, watch the video all the way through. Go over to gcbasic.com and donate, or go to coffee.com and donate. So why am I doing this video? Because I got this video on Christmas Eve. I used the GLCD demo from Howard. I modified by removing most of the things that were displayed, but left one. I added an LED light. He says, turn on the backlight. All I get is a blank screen, except the LCD lights up and the backlight comes on. I suspect CS1 and CS2 are active low, but it looks like the KS0108, and I'll explain what that is, driver, has an active high. But I'm not sure if I am correct. But if I am, how do I correct them? I attach my demo. Absolutely brilliant. And we've resolved this. And that's what this video is about. Because to have a deep dive is actually quite interesting into the operations. So let's recap. GCBASIC open source compiler, pick AVR's LGTs. It supports 1400 microcontrollers, and it's a common platform with common code translation. So let's have a look at how it works, the compiler, and then we'll look at GLCD in detail. For those who haven't seen this before, basically we take the source code, we take some libraries down here, we take some information about the chip, quite a lot of information, and we pull that together during the compilation process, and we pull that information into here, and we pull the libraries in. And one of those libraries happens to be for the graphical LCD, or GLCD as I will now call them. Goes through a code translator, assembler, produces some output files here in terms of reports and assembler files, goes through the linker and produces a hex file. It was doing that all very well, but clearly Howard had spotted there was some issue inside of a library, and that library was one of the GLCD libraries. And I'm surprised he even found it, because it's without this video, it's quite hard to wade through. So let's look at GLCD, concept of operations. Supports the same sort of, the libraries support 38 devices. All the public functions are in the help. Conceptually, all the public functions are in a solution specific or hardware specific library, a .h file, and that .h file will contain all the public and many private functions to that particular device. So what we've got is a way of publishing things, and we're going to show you how those work. So look, here are some of the commands. These are from the help, and these are common commands across all the 38. So if you want a box, you just say box. If you want to print something out, you just say GLCD print. Why the difference between having the prefix of GLCD and line? That just goes back to 2006, when the first driver for this particular GLCD was written, and I think they're just a legacy. So maybe we should translate everything to GLCD, because that would be better. But I'm just saying these are all the public functions. So how does it operate? So what we've got, we had that horizontal diagram before, but it's worthy of note that what we've got is a user program that's calling a library, and that library is a GLCD library in this case. But there's over 125 libraries through here, and it's calling one or more of those automatically. Those libraries may call a low-level function, and that low-level function in this particular case is going to write to the ports. It doesn't use USART or I2C, SPI. It just writes to the ports. And that will generate a machine-specific hex file, but it will also write out to things like the GLCDs and other hardware. So think of it like this layers, because these layers are sort of important in the conceptual operation that says, okay, I've got to use a program. How do I call all these libraries? How do I call all these low-level functions? And that's what we're going to go deeper into. Because to make a GLCD work like this, I'll show you one that's working. Here's one that's working. Here's a GLCD here. If I turn the potentiometer, it's a simulation, and I'll go into this in a while. It's drawing things on a GLCD at high speed, right? Okay, there we go. Fantastic, great. All you do in your program, in reality, is just give it a couple of commands. And one of those commands happens to be something called an include file. And that include file says include glcd.h. Well, that in itself kicks off a set of operations inside of the compiler that automatically load a series of other files. And we'll see how we control those. But this thing, there's another support file called glcd.h, and that says, for this particular type of device, KS0108, I need to load something. And in reality, there's a little file called glc.dat, and it has a little list. It says, if I want that type of GLCD, load this file. But look down here, if I want to type ILI 340, I need to load the 340 library, but it's obviously got an external call into another library. And so if the one command of an include statement doesn't reveal all that's going on, and why was it optimized? I'll explain. So all these library files of these GLCD have a prefix of GLCD underscore. I think there must be 40 of them. And all the GLCD operations are dependent upon that file called glcd.dat, and they control which additional .h files are loaded in. And the reason for that, it saves compilation time. If in the dark years of GCBASIC, we used to load all the libraries, and it just got slower and slower the more libraries you add. So this bit of automation goes on, and it goes into glc.dat and loads the correct files. But the one that I'm going to be looking at today is called a KS0108, one of the oldest GLCDs. It's just automatically loaded when you load GLCD.h. If you have an include statement like this, include glc.h, it just loads it in, because it's the obvious one to load, because it's got many of the core functions in it. So how does this all work? Inside of a GLCD library, they all have some common functions. They all have something called init GLCD. They all have a clear screen with GLCD, clear screen. They may have a fill box, but they always have a preset. And preset I'll drill into deeper in a moment. So as I've said, they all have a suffix of the device name underscore something, and then in this case it's KS0108, that's the one we're looking at. And these libraries, share many of the same functions. They share lines, strings, numbers, triangles. They're all the same. It's the low level stuff for a specific GLCD that needs to be written. And that is typically, as I've said, the init, the clear screen, filled box, and preset, because different GLCDs have different ways of doing that. But that's abstracted from you, because if you call GLCD clear screen, this command here, it actually calls something else. And the compiler does that magic for you. It says, go and call a function called GLCD CLS underscore the device name, in this case CS0108. And the same for the init GLCD, the same for fill box, and the same for preset. And preset is pixel set, and we'll look at that in a moment. And all this is held within the setup files of when all you have to do is include the statement, include glcd.h, and all this happens automatically. Because that's how all the functions work. So here is something called GLCD CLS, and that has the potential of calling 38 different ways of clearing that screen for each specific device. And as I said in the previous slide, it will have a suffix So it will know which one to go to because you've told it one in your configuration. But as we go deeper and deeper and deeper, let's say we need to set a pixel. And we need to set a series of pixels using the line function, for instance. Line has four parameters, an XY and another XY. So that's the start XY and the end XY. And it's going to call something called pset many times. And pset, it gets called. And that pset may call something that sets the ports, something that uses I2C or the SPI. And so if we look at line as the example, line, the function line, does all the maths and it's common throughout all the GLCDs. pset handles the XY specifics for one pixel set. Those calculations on the data is then sent to the GLCD, and pset may call the underlying comms protocol like port, I2C, etc. It's basically the read-write routines. But you've got a line function, it calls pset does all the calculations, and then it says go update the screen through the read and write functions. So what you've got is core operations and the public functions. There are a set of handlers, and they're quite complex. But in reality, you can decompose these, and they're pretty well documented anyway. So let's look at pset. In this case, for the KS108, the pset, it handles things like the inversion of the screen. You can literally flip the screen. And then it sets the Y position, the Y page. It's called a page actually on these displays, and it's an 8-bit position. It sets the Y position where it is on the screen, which page it's on the screen. Reads bytes in from the device. It compares that bit that it read in to the pixel it's setting, so the desired pixel state. It sets that byte. If the byte has not changed, it doesn't do anything because there's no point in sending it. It reselects the X position, sends the byte out using the desired protocol, and something puts it on the screen, and that's typically the screen IC. So pset is a way of actually determining which pixel to set in the many thousands on these GLCDs. So pset is critical, but going back to the original email, Howard spotted inside of pset there was something that selected the CS1 or CS2. And I was really surprised because I have in my set, I have here maybe 30 or 40 different GLCDs called the KS0108, and they all worked. So why did Howard's fail? I pulled out a GLCD, plugged it in, and then we'll go through what I found. Quite remarkable. I'm pulling my sleeves back here. Let's look at what's going on the screen, okay, on the camera. Let's go to the camera. Look, I've got a GLCD here. If I press the reset button, it's just going to count through it. Now, this is actually Howard's program. I've helped Howard sort of sort all this out over the last day or so. And basically, look, we've got here something that actually is like a speedo. I don't know the details of what the solution is, but all this is coming from a very simple program of a GLCD program. It's coming through, and I've optimized the fonts for him. These are his fonts, not mine. And basically, they're writing quite quickly. Now, this, maybe zoom out. I mean, I'll zoom out. There we go. Look, this is my board, and in here, look, I've got a connector for a GLCD. It's upside down on the screen, by the way, so I'm having a bit of difficulty here. It says there, look, it says here, GLCD. Let me have a look. 128 by 64. Says it there. So all I had to do to make it work, I should really disconnect it, I suppose, is write a quick program, shove it, push that in there. I can't get it in. Push it in there, put some power on here, and voila, it burst into life. Not his, I mean, just a test program. I just put a test program in. And I couldn't understand it because this works. If I go and get another one, I'll literally go and get another one. I went and got loads of these things because I was completely baffled. I just put another one on. That's a different one, is it? Is that different? Does it look different? Looks pretty similar. Maybe I'll go and get a different one just to prove it. Okay. Reset. There you go. It works. Now, the power cable's been pulled here slightly. Let me just go and get another GLCD. A completely different one. Hold on. I put them away. That's what I did. I want a GLCD that's not one of those. Oh, there's some nice ones in here. This is nice. What's that? Oh, that's nice. Different one? Is that different? Is that a different one? No, that's very different. That's very different. Don't do what Evan does by unplugging things live. That's bad practice. Hit the reset. Hey, that doesn't work either. I might have plugged it incorrectly. Ah, that might be a timing issue. That's genuinely interesting. Oh, is there something on that screen? Oh, I'd imagine it's the backlight. It's the backlight, of course. The backlight needs to be adjusted. There we go. It was the backlight. I forgot to adjust the backlight. There we go. And as you can see, that is working okay. Now, and it's working the same as it was before, look. So the backlight was a bit messed up. Isn't that great? So I knew it was okay. Howard then ordered me up. He sent me. Oh, you can't hear me. Howard ordered up. It was the backlight, by the way. That's what the problem was. Howard ordered me up another one, another display. As you can see on here, that is now working. It's upside down, but never mind, eh? It's only upside down because of the camera. Let me just transform that. I'm just transforming the display for us. There we go, great. So here we got the same program running, different chip, doesn't really matter. But what on earth is going on? Look at that. Let's have a look at the program. Let's have a look at the program. Here's a demo. Essentially, what I've got is I'll get another one of these boards out. Actually, I'll get another board out, and then you can have a real good look at it. Screen cam. Here's another board. I need the desk cam. Let me leave it there. That would be fine. Let's see if I can do this upside down. So if I look at that connector there, turn it around like that. There we go. Nope, you can't quite work it. It's still staying in focus. I want to get this in focus. So let me just zoom that up. Let me zoom that out of the way. Oh, there we go. So look, what we've got here is a load of connections on this board. It says here LED plus VEE. It's just down here, like you can see it here. It's down where my fingernail is. Reset CS2 D7 through to, if you look right the way through, RS. And this connector here also has connections for 5 volts, ground, and the contrast. There we go. So this board was designed for this particular GLCD, and it worked well. So that's another board. For those who are counted, you've seen quite a few of these today. Okay. Now, it's upside down. Please do not worry. That's not the issue. Back to the program. So you have to set up the GLCD, and you take all those little connections, and you connect them up. And we know that worked because it worked previously. So how did I get his working? Well, here is the program. To be quite frank, it doesn't matter what it shows. It wasn't working. It didn't say hello. Okay. But to set this up, you set up all these constants, and they're fully documented, and you say to it, include this command here, glcd.h. Remember that it automatically installs the GLC KS0108 drivers. And how do you know that? Because you set the type. So you create a constant called GLCD type, and there's 38 different types that you can choose. And that is it. Okay, that's done. You go, what type of font you want, and then it does the magic that you've seen on the screen. But for Howard, it was not working. That's because his chip, his is not the same. Let me just pull this out. This looks like a GLCD. It looks like a KS. I pulled it out. Look. This looks. Let me go and get another one. It looks the same. Let me just get that on the screen. They look the same. 20 pinouts. Look, it looked identical. You flip it over. It's got 1, 2, 3 dots, 3 ICs, and basically one of these is the KS0108, and the other two are KS0107s, and that controls one half of the screen. And there's a little in here. It says CS1, CS2, and that controls one half or the other half. This is his. I'll turn it upside down so you can see it. As you can see, I've written on here SLG12864G datasheet. It's use the datasheet. It's not a KS0108. It's very similar, but it's not the same. And what's the giveaway on here? The giveaway is that there's a non-standard 20-way pinout. It is 5-volt tolerant, and you have to now put in the compiler GLCD KS0108 CLS low. And what I did, I figured out that these connections are the clue. Is that you can just about CS1, CS2 is on pin 1 and pin 2. Let me reassure you, they're pin 13 and 14 on this one. So that's why I've got this mess of a board here. Okay. I was looking for something that actually had them on there. Oh, I've got another one here. I got loads of them. So what I had to do is invert CS1 and CS2. What I did, I printed that on there, look, so I can track it in the future. Look, I put it right on the edge there, so I can. It's upside down. You can just about make that out. You can just about get it in focus. So what I've done, I've actually changed the compiler, not the compiler, the library. So I've looked at the library. I've included a new switch. And that constant will enable these new ones, these different ones to work because they're not a KS0108. They operate almost the same, apart from the fact that these two control lines operate in a very different way. And so in the program, if I look at I'll just look in this one because it's a very special program, but I've done exactly the same in the library. I've said, if this constant exists, KS0108 and CS low, then these control lines are toggled. They're the opposite of what the norm is. And because they were the opposite of the norm, I can then sort that out because this constant gives me conditional compilation. So now I've got a new constant to control these new GLCDs. And these new GLCDs are the actual integrated circuit is an SLG 12864, not a KS0108. It operates almost the same, okay, but it's not exactly the same. It's not perfectly the same. And so in here, in this particular program I published for Howard, it looks after all the fonts, etc. It does all that stuff for him because he has specific needs. And I'm just cursoring through. Let me just Control A, Function F2, fold all. I've minimized it. Basically, what he's got is a way of doing fast writes. If I plug this back in, we can see all that working for us, so it's quite exciting to see. I'm just going to plug it back in here on the bench. I'm just going to hook up my programmer to this particular board. Remember, I had other boards plugged in here. There we go, it's plugged in. If I go to Zen mode, or what I call Zen mode, which is this mode, you can see it's just sitting there ready to rock and roll. Is it? Is it ready to rock and roll? Oh, it is. It's back. So I've done all that. So let me just pull up that program. I'll pull it up out of the demo folders, and now I've actually called it demo gauge for inverted CSX lines. Okay, CS in the CS1, CS2 lines, and in here I've got that constant, and here's that constant CS and GLCD KS0108 CS underscore low. And so if I program that now, function key F5, it should program that. It should program it. I've been pulling boards and GLCDs out during this video live, which is not a good thing to do, but I've tried it. It's erasing the part now, and it's done it, hopefully. Oh, definitely, because it's reprogrammed it. So what we can do, because we've got this little program in front of us, we can have a little play. So look, in here, I can, let me just think where I did it. Oh, here's a function called fast write a byte to the GLCD. And I can put a little delay in here, put a 20 millisecond delay, and we can see the pixels being updated, which is fantastic, really. This won't be in the live program for Howard. This is just one for you, so you can have an understand what this is doing. So what it's doing, it's reading in a table of fonts, this very large character set. It's reading that data in, and it's drawing it on the screen like that, look. And if you watch it very carefully, as it draws those large characters, you can see that the actual overwrite is fully optimized. So it's not actually writing 48 pixels by 48 pixels. It's writing a lot less. And you can see, there we go, that the whole of the 5 to 6 transition was only a handful of bytes, because it automatically calculates that. And so what it's just doing here, it's just doing a rundown, so that it's initializing the screen. But here's a slower operation. A 2 to a 1 takes a lot more operations quite clearly. And then it's now operating as normal. And if I change the potentiometer, there we go, it's settling down to 27. That must be where the potentiometer was. And I've just changed it to 50 something. You can see it's actually drawing it out. It's reading the pixels in from the GLCD using these private functions, writing them back. And I've written him a replacement program so that he can write. He's actually got a different font set. And that little font set is in here. We look to the number 2. Woo. Yeah, one would say that table 2 is missing, but is it really? Oh, it's tabbed in by 1 byte. Look at that. So basically what you've got for the number 1, let's have a look. Let's try and get a 1 on here. Here we go. I'm just changing the potentiometer slightly. Number 2, there's a 1. Obviously, I've got the delay in here so we can see it. And it basically says here, it just drew out 26 zeros. It did 1 120, 1 124, 1 126. And these are the byte values going to the GLCD. They're actually the byte values. A better number to look at might be 8 in reality, because 8 sort of gives you a good clue. Oh, there's an 8. Look. Is it going to stay on the 8? Yeah, let's look at 8. Oh, it just changed. Oh, I'm happy with a 0. 0. It says table 0. Draw out 6 times a 255. So do that send that out. Send out byte 6 times, send out the number 255, send out 32, 32 times, send out the value of 31. And so this is the shape of that character, and it's optimized because the original number of bytes to be sent for this was huge, and it wasn't optimized. So what we've got is a way of using GLCDs. This resolves a particular problem for the KS0108 because it's not the same as this other device. But I hope this has given you some insights that you've got all these functions that you can use, and that in reality it's quite simple to use. I mean, you do the setup at the top of this program. You do the setup like I showed you before, GLCD settings. You set the constants, and then you've got public functions that you can use. And I've also shown you can write your own, as in this one. Here's a public function, GLCD, write something. Here, there's a better example. GLCD position 2247, put the letter F on there, and there is an F on the screen. If we zoom in, we can see that. There's a letter F on the screen there. It's down here somewhere, the letter F. And if you want a degree character, if you want a degree because it's not in the font set, you can do your own lot. We could make that Taito, I guess. But look, it's quite flexible. So I'm using public functions here, and I've written my own function for that very large font set. So you can do a tremendous amount, and this will work across the majority of the GLCDs. When you come to these specific operations to this specific GLCD, there was nothing wrong with the overall libraries. There was just an implementation change required to support this slightly different GLCD. So back to my slide. Hence, this said KS0108 in the lab, but there's an SLG 12864G. It's sort of a KS0108. It took 2 lines of code to fix his problem. All the font stuff, that's different matter. But GLCD is extremely powerful. Let's have a look at and close out. I hope you found this interesting. GLCD deep dive, concept of operations, how it all works. You've seen some different GLCDs, you've seen some of the operational issues. Use the public functions and extend it and just write your own. Enjoy.